So here we'll discuss the remaining problems of differential equation. So the problem one is says that this is problem number. So consider the differential equation. Differential equation y dash is equals to y minus 1, y minus 2. Which of the following is true? Which of the following is true? So A says that if y of 0 is 0.5, this implies y is decreasing. Option B says that if y of 0 is equals to 1.2, then y is increasing. Option C is that if y of 0 is equal to 2.5, then y is unbounded. If y of 0 is less than 0, then y is bounded below. So that's what is important. So now solution, will try to find the solution. So the solution says that if y of 0 is equal to 0.5, then y dash 0 will be equals to 0.5 minus 1, 0.5 minus 2, that is 0.5 into minus 0.5, that means minus 1.5, which is greater than 0. This implies y is increasing. Possible case, possibly. This is the probability. May not be increasing but cannot be decreasing. But what is important, y cannot be decreasing. From here we can say this, that y cannot be decreasing. So y is decreasing says that, so option A is false. So now if we look at the other case, that means now what we have given is that y of 0 is equals to 1.2, then y dash is equals to y into y minus 1 into y minus 2. So 1.2, y dash 0 is equals to 1.2 into 0.2 into minus 0.8. So it is less than 0. This implies y dash cannot be increasing. So y dash cannot be increasing. So what is given here, y0 is this, then y is increasing, but we got that cannot be increasing, right? So this is for in option C. It is given that option C says that y0 is equals to 2.5, then y dash 0 is equals to y of 0 minus 1 and y of 0 minus 2. So it is equals to 2.5 minus 1.5 into 0.5. so it is greater than 0. This implies, so what we have, if we try to plot in baby curve 0 1 2, so greater than 0, so that part will be this, and what we can say that y is unbounded. We can say that y is unbounded. So y is that this is true, and this will be false, because we can take an example putting by, say, y of 0 is equal to minus 0.5. then what we will obtain, this value will less than 0, and if this value is decreasing, and decreasing doesn't imply that it is now bounded below, so this will be false. Now in 2000 December 2013 MSQ, there is a MSQ question, right? So what is question says that, question number 5, y is equals to r from r to r satisfy the IVP, satisfy, this is problem for satisfy the IVP initial value problem. What is satisfy? It says that y dash t is equals to 1 minus y square t, right? T belongs to R and y0 equals to 0, 10 y of t1 is equals to 1 for some t belongs to R and b y of t is greater than minus 1 for all t belongs to R. See, y is strictly increasing in R, and D, option D says that y is increasing in 0, 1 and decreasing in 1 to infinity, right? So that's what y have the properties, right? Now what we have to solve this equation. So solution will be that y dash dy dt is equals to 1 minus y squared t. So this implies dy by 1 minus y squared t is equal to dt. So dy by 1 minus y into 1 plus y is equals to dt. So what we can write, half of, this implies half of 1 minus y plus 1 plus y dy is equals to dt. So from here what we can write, this implies half of integration of 1 by 1 minus y plus integration of 1 by 1 plus y, that's dy is equals to dt. So integration of dt, this implies half of log of 1 by y minus 1 by y minus 1, because certainly, so okay, so it is will be equals to half of log of, it is okay, 1 by y minus 1 plus log of y plus 1 is equal to t plus c. So it is equals to, this implies 2t plus c. So it is equal to log of y plus 1 divided by y minus 1 is equals to 2t plus c. So what we will have, y minus 1 plus 2 divided by y minus 1 is equals to e to the power e to the power 2t. So it is equals to, if we break 1 plus 2 by y minus 1 is equals to e to the power 2t. So what we have, 2 by y minus 1 is equals to e to the power 2t minus 1. So what we'll have, y minus 1 by 2 is equals to 1 by e to the power 2t minus 1. So what we will have, y minus 1 is equals to 2 by e to the power 2t minus 1. This implies y is equals to 1 plus 2 by e to the power 2t minus 1. So that's what is the value of y. Now we will have to solve this. So so what we need, y of option A said, so what we get, y is equals to, now y of t1 is equals to 0, y of 0 is equals to 0, y of 0 is equals to 0. This implies 1 plus 2 by a minus 1 is equals to 0. This implies 2 by a minus 1 is equals to minus 1. This implies 2 is equals to 1 minus a. This implies a is equal to 1 minus 2 is equal to minus 1. So what we have, y of t is equals to 1 plus 2 by a means minus 1 e to the power 2t minus 1. So what we will have, 1 minus 2 by e to the power twice t plus 1. So that's what is y of t will look like, right? So that is what y of t looks like. Now y of t1 for some t1, say y of t is equals to 1. This implies 1 is equals to 1 minus 2 by e to the power twice t plus 1. So this implies 2 by e to the power twice t plus 1 is equals to 0. This implies 2 is equal to 0, so not possible, it is a contradiction. So option A is false. Option A is false, right? Option A is false, because if it is happen y of if y of t is equal to 1, this implies 1 is equals to 1 and is equals to this, and we will now if we look option B says that y of t must be greater than minus 1. Now y of t is equals to 1. This is the value of this. So y of t is greater than minus 1. This implies 1 minus 2 e to the power 2t plus 1 is greater than minus 1. So this implies e to the power 2t plus 1 minus 2 is greater than e to the power 2t plus 1 minus. So this implies so e to the power 2t minus 1 is greater than minus of e to the power 2t plus 1. This implies 2 e to the power 2t minus 1 greater than minus 1. So this implies, so this is minus 1, 2 e to the power 2t is greater than 0. So e to the power 2t is greater than 0. So that's a true statement, because this is true statement. So option B is true. What we get, this is false statement, this is true statement. And since it is a MSQ, so we have to check more. Since yt is greater than 0, now what is the value of yt? Yt is equals to 1 minus so this is yt, and y dash t will be equals to that, so here will be minus e to the power 2t plus 1 of whole square e to the power and again there will be minus of 2 into 2 e to the power twice t. So which is equals to 4 e to the power twice t divided by e to the power twice t plus 1 whole square. So that should be greater than 0. So strictly increasing, so strictly it cannot be 0. Why? Because here it cannot be 0, strictly greater than 0. So that one is another statement. This is false, because and the decreasing cannot be decreasing, not possible, decreasing is not. So option B and option C are true options. So we'll now come to the next questions, right?